Okay. Okay, so first of all, we have homework due tonight. So if you have not submitted that homework that was due from Friday, it's due tonight, but it was from Friday. It was first derivative with chain rule and all that good stuff, and exponentials and radicals and changing things to powers. That's due tonight. Make sure you're getting that submitted to me. So it's by 11:59. We have some notes today. We're not going to get an assignment on this stuff. You're going to get a Google question of the day, and that's something I will grade. So today's thing is, it's one question. It asks for if you were to graph the second derivative graph, okay, and I provide you a picture on Google Classroom. If you were to graph it, where would you hit the x-axis? Where would be the x-intercepts? No, you just have to tell me where it would hit the x-axis. So that tells me that you're graphing it correctly. Okay. So all right. So let's walk through a couple problems here. Thanks. Okay. All right. Okay. Yep. All right. So let's walk through a couple problems here to make sure that you guys. All right. Anyway, let's go through a couple notes, and then once we're done, then I'll give you time to work on the assignment. I'll give you time to work on whatever you need to. I know there's a lot of tests coming up. I think there was Spanish tests today. There's a bunch of tests next Monday and Tuesday for everybody. I'm putting my tests on Friday. There's probably some tests Friday. I understand that. I'm avoiding Monday and Tuesday because I have this itching feeling a lot of people are pushing their tests Monday and Tuesday just to make sure it's after midterm. I just enter mine after midterm. That's all I do. So it works out both ways, and I get the weekend to grade it. So let's walk through the first derivative and second derivative. Remember, homework is due tomorrow. Tonight, 11:59. So question.
I will not be here Friday. I'll be at a college visit.
That's fine. You'll just take it next week then. So yep. Well, because you're back one of those days next week.
Friday?
No, he's gone, so he's just going to come in next week and take it.
We're all taking it online.
Oh, we'll be here, like he can't take the time. Okay.
Yeah. Okay, all right. So let's talk about the graph. So I want to discuss like what you need to do on that Google question. So let's say that the picture I give you, let's say that the picture looks something like this.
This is first derivative.
Let me get rid of that arrow. This is the original f of x.
Or,
I gotta try this one.
can you please put in a reminder somewhere that I gotta go turn in my physics homework?
At what point?
Just I can't forget today. Because I don't want
Set a timer for 20 minutes. All right. Now, let's discuss how to graph this. This graph is my original f of x. We have a lot of stuff going on here. So what we're looking at here is we're looking at slope, and we're looking at all these points. So on this left side here, my slope is positive. Now, do you agree that this was not a curve?
Yes.
It will, when I graph the slope, I actually need to find what the slope is or estimate what its slope is. So it's a constant, it's a positive number, it's constant. It looks like it's going kind of like maybe up 1 over 1, up 1, maybe not. Maybe up 1 over, so up 3 over 2 maybe?
It's up 1 over 1.
It looks like up 1 over 1. Let's just go up 1 over 1. Let's say that. Okay, so let's say my slope is up 1 over 1. That means 1 over 1 has a slope of 1, right? 1 divided by 1 is 1. And it's going all the way up until about -3 on the x-axis. It has a slope of 1 all the way up to -3 on the x-axis. Does that make sense? That's where it had a slope of 1 over 1. So notice that horizontal line. My y numbers represent my slope. My slope was 1. It's constant, flat. Then, after this point, from -3 up to, what is that, 2 on the x-axis, my slope is 0. My slope is 0 up to 2. Because it was a flat line. Slope is 0. And then, it was negative. It was negative slope up until about, what is this point? Negative
6, 4, 5.
Yeah, it's 5, positive 5.
How people can count that.
So, yeah. So it looks like 5. So the idea is that it's got negative numbers and it's slowly ramping to 0. So it went from negative numbers and it's slowly going back to 0 at 5. Okay? So it kind of rounded off a little bit, and then it's going to go positive at that point, and it's going to ramp up to be positive after the number 5. So it's just going to go kind of up, and it's going to be a curve. It won't be a straight line, it'll be a curve as it goes up. This is my slope. This graph represents slope as I go from the left side to the right side. The part that gets people is like, how do you know? The slope is going to be my y numbers. So I'm like, you could plot each individual slope at every moment and then just draw the dot where those slopes need to go, or just kind of ballpark it. My slope is constant, so it's a nice number the whole time. Then it hits 0, okay? Then I make sure I hit 0. And then it's got to be negative for a while, and it comes back to 0. So then I just kind of round it off. That's the idea, okay? So this is the first derivative graph. This is the first derivative function, and I just want to make sure that this makes sense, like how we're actually drawing this, okay? It's one of those things that's really hard. What I always focus on is where do I hit 0 slopes? If I can plot where the zeros are, then I can fill in the gaps between there. That's my little method for doing this. Sometimes, like I've been doing this long enough, I can just look at each individual part separately and just kind of map them out in my head. Just chunk it out like I'm doing here. The left side, the middle, the right side, and then keep going, and I just kind of break it up into pieces. And I just kind of plot them and make sure that it flows.
So what did the people last year not get that?
What they're really struggling with is like, why is that, like, so if we look at the far left side, if we look at, I'll put this in a weird color. If I look at this side over here, they're really struggling with, like, why is that a horizontal line? Because this slope is positive. Yeah, because the slope stayed the same number the entire time. It wasn't like it was a curve. It was just a straight line. So it means the slope is staying the same number the entire time. So when I go plot what that slope is, it's a solid line. It stayed the same slope.
2/3 would be at 1.5.
Yeah, it'd be 2/3 is like 0.6, right? So I'd draw it 0.6.
3/2.
3/2, that'd be 1.5, right? Yeah. And I'd go find 1.5 and I draw that horizontal. But on my case, on this one, it was 1/1. So I go and find it. So that's the idea. That was the part that they really were struggling at. It was like those slopes are representing the y numbers on this next graph. That's what we're doing.
So if I picked that was, and I said that was up 2/1 just because
It looks like 2. Okay, fine. Yeah, you just have a horizontal.
So on the test, if I do like, it's at 2 instead of at
Yeah, that's
1.
fine. Because it's just giving me a little leeway. You're just giving me a ballpark of what you think it's doing. I should see that there's a horizontal at some point. I should see that maybe there's 0 for a little while. And then I should see that it's dipping. Like it's not, you won't be at the exact numbers like I'm doing. I'm just guessing at it, right? I nearly said that slope was 3/2.
You didn't dip to a certain depth. Right?
No.
You just went a certain
I just kind of went a certain length and just kind of rounded it off. Yeah, so it didn't matter how deep it went. I need to be in the negative area. So yeah, so that's the cool part about this. There's a little bit of wiggle room. But yeah, you just got to get that first baby steps into it. So let's do another one. I got 3 more examples I want to do, and then we're done. So let's do my next graph here. So let's say this graph. Let's do something like this. So now it's kind of going up and down, right? So as we're going through this slope on this far, I'll try to put this maybe in yellow. On this far left side, this is negative slope. And eventually, at this number, I'm hitting 0 slope.
-1.
That's what? 1, 2, 3, 4, 5. That's -5, I'm hitting 0 slope there. Does that make sense?
Derivative, you take a line up. So I bet our thing over here is going to look, oh, no, but it's actually.
Yeah, so, okay, so on the left side, I have negative slope, and it's going up to 0 at -5. So 1, 2, 3, 4, 5. So here's -5, and my derivative is going from negative numbers up to 0, right there. So that's an x-intercept. It's slowly approaching 0 on that slope. Okay, and so there was an arrow on this side because it was staying negative.
So would our second derivative this be like a parabola?
Probably, yeah. Yeah, every time you go down, it's got one less oscillation. So, yeah. Okay, so now next, on this side, now we're hitting positive numbers. So positive numbers up until about, what, the number 2, -2 here, when it hits 0. So it's going to be positive numbers up until it hits -2, and then it's going to come back to 0. So it's going to have positive numbers until it comes back to 0. Because again, I'm plotting that, and the 0 slope represents 0 on the x-axis, so I have another x-intercept there. Then I'm going to go negative numbers for a little while again. It's going to have negative numbers for negative slope until about 1, let's say. And that's where it hits 0 again. So negative numbers until it hits 1, and then it'll be back to 0. Boom. And then it's going to go positive at that point. This is positive slope for the rest of the time, so it's just kind of go up. This is what my graph looks like. Rough guessing. Okay.
That's first derivative.
First derivative graph. So this would be my original function. and this would be my first derivative graph.
And we're finding the second derivative.
Okay, so if we want to do second derivative, I'll plot this next. So this will be like what you're doing in your Google question of the day. I give you an original graph, and I say I want the second derivative graph, and all I need to see is where did you hit the x-axis? Where are the x-intercepts? You're not drawing. You're not going to submit a picture to me. I just want to know where did you hit the x-axis? Give me the ballpark numbers. So if I'm doing my next graph, I'm going to go off of this one, right? This graph. And I'm going to tell me where I hit the x-axis. Yeah. So I can tell you I'm going to hit the x-axis twice on the next graph. So if I'm going to do this one, I'm going to redraw this one. So what do we have? That's -5 and -2 and 1. All right. So let me draw this next picture here. I'm going to continue this drawing. So, all right. So -5, -2, and 1, and this is kind of what my graph just looked like. Okay, that was that last drawing we just did. This was the first derivative graph. So now I'm going to redraw it again and do the second derivative graph. F double prime. So we're going to have positive slope for a while until it hits 0 at about, what is that, about negative 3.5, 4-ish? Probably -4, kind of that ballpark. So we're going to have positive numbers up until about -4, where it hits 0. Positive slopes. Then after that, it's going to have negative numbers up until about -1. So negative numbers up until about -1 where it hits 0. And then it went positive at that point for the rest of the time. So it looks like a parabola like you said. Every time you draw the next graph, like first derivative or second derivative or third derivative, it gets one less change of direction.
And you flip your max and mins into x points on your axis.
Yeah, I mean, yeah, that's a great way to think of it. The max and mins, like those highest and lowest points on your peaks and valleys, those are literally your x-intercepts on the next graph. That's a great way to think of it. And that's literally what I'm looking for, is like, you're finding, like on the question, the Google, the question of the day is like, on the second derivative, where did I hit the x-axis? Where are those x-intercepts? Well, duh, it was the peaks and valleys on the first derivative graph. So it was the peak and valley there. So I really wouldn't need to draw the second derivative. I can tell by the peaks and valleys. But on this case, I'm hitting -4 and -1. Those would be the numbers I'd want to see in Google Classroom, right?
When did we have to do like peaks and valleys last year? Was that with like
What we did differential quotients. And then we've done it this year where we did first derivatives and we looked at peaks and valleys. We showed shortcuts for doing that. Questions?
So if we had, like on this graph, a third derivative, or
Yeah.
do a second derivative on like a parabola,
Yep.
would it be just a straight line?
Straight line, yeah. Yeah, because it gets rid of it and it turns into a straight line, and then eventually it turns into nothing. It turns into flat at 0 the whole time. So, all right. Okay, so that's what we're doing. So that's the idea of the Google Classroom question. Let's do one more, and this is our last one today. Last bit of notes today. I just want to do one more graph. I'll just kind of make up something that you can see it. All right, so here we go.
Pop off. Not that crazy. Calm down.
No, yeah.
Okay, last one. This is the original graph, and I just want the first derivative graph. If you can understand this, you are more than fine doing the rest of these. Okay, because this is way harder than anything I'd provide you on a test.
We're at 5.
So-
-5.
So, yeah, about -5, I'd say about that. So that first, getting to that 0, that's 1, 2, 3, 4, yeah, I'd say about -5. That's where it's going to hit 0, so that's -5. So it's going to be positive slope up until about -5. 1, 2, 3, 4, 5. Here's -5. It was positive slopes up until that point. Then it hit 0.
That's gonna be the hardest part for me, thinking positive, and I gotta.
Yep. Yeah. And then it's gonna have negative slope until about -2. So -2, it's gonna have negative slopes until about -2.
Then a line at 1.
Then it's gonna have a, what is that, up 1 over 1? Yeah, it looks like it's up 1 over 1. So this slope going like, it's a straight line, so you have to actually calculate it. It looks like it's going up 1 over 1 for a while. So 1 over 1 up until about 4, right?
Yeah.
So it's gonna have that slope perfectly at 1 the entire time.
7.
That's a constant slope, and then it went negative for a while. So it went negative up until about negative, or up until 6. So it went negative numbers up until about 6. So that's about to here, right?
Yeah, I think so.
So it went negative up until there.
I should shut up.
And then it should turn positive. And that should be a curve, sorry. That should be more of a curve. Because it's actually curving. It's not being a straight line, so.
Easy.
Oh,
That's pretty easy.
So.
my god.
Yeah, if you can understand like what we did there, you are more than fine. Because the stuff I'm providing you on the test, you know, it'll be just a graph and it'll say find the first derivative, find the second derivative, and I'll provide the 3 graphs for you and just put them one back to back to back. It'll be something simple. Like this is complicated where you have to like stop and really look at the next piece and
You should
stop.
give us the test after you teach us each day. Then I would have 100%.
That's what you have notes for.
Okay, taking notes about this stuff is not easy.
You just gotta learn, that's something you gotta learn when you get to college, is like when you take notes, you're not just taking the notes that the professor's doing, you're taking all the little stuff you need to remember how to do it. That's the part. You're like, sometimes you don't need to take every note, you're just like, okay, this is the process we do to do this type of problem. And you could be ignoring them for a while, just writing down, this is what I need to remember. So. Or what I did in college, just record them. Just record the lecture, and then you just take notes whenever you need to.
Yeah, we tried that in B's class.
Yeah, understandable.
Probably because he goes through the exact test.
Yeah. Okay. All right. That's it for today. So for those at home, you guys can log off. You can go work on your Google question of the day. You are not submitting any pictures. You're just telling me where it hits the x-axis on like the second derivative graph. And if you guys need any help, I'll go through another example. I got plenty of graphs here. But the rest of the time is your guys's. You guys can work on your homework that's due tomorrow. That's the worksheet I gave on Friday. It was on chain rule. We have tests this Friday and a midterm. Grades will be updated tonight. Sorry, I got hung up on the geometry sections. I just finished geometry like 2 periods ago, getting all the grades submitted. It was just a train wreck trying to get all theirs organized. And then you guys will be tonight on the docket, so you guys can see what you're missing. So. All right. There you go. All right. For those at home, if you guys have any questions, fire away. If you don't, I'm gonna stop the share here and take some screenshots here before I forget. And stop my recording.
Did you make sure you recorded?
Oh yeah, I had a sticky note on my desk.
I was thinking about that this morning, and I was like, you know.